Welcome to the second video from Chapter 2, Section 8. This time we're going to focus on using sign charts to help us with rational functions. So we're going to be looking at this rational function, and we have basically just gone through how would we actually think about finding the x-intercepts and the y-intercepts, the end behavior, any discontinuities, and then graphing that and using that to help us visually see what's going on. A faster way might be to utilize this idea of a sign chart. So if we look at this, I'm going to make just one really big sign chart here, give myself lots of room. What I notice, I can still do some of the same things that I did before, but I know from the denominator that at x equals -3 and x equals 1, I'm going to have vertical asymptotes. And then from the numerator, at -1/3, I would have an x-intercept. So I'm going to mark that again on my sign chart. So we have in order, so -3, and then a -1/3, and a +1. So I don't care about spacing it out exactly where it should go, but just more to give myself plenty of room to work. And we're going to kind of go through it and think about this the same way we did with our previous example of a polynomial. So I'm going to just pick a number, and I generally start right in here because 0 fits right in there. But whatever value I picked from there, as long as it's between -1/3 and 1, I'm going to get the same sort of output, the same sort of sign for the overall chunk. So if I plug a 0 in, especially into the numerator, well, actually I want to do one more thing first. Okay, I forgot to mention this. Just like we did in our last example, I want to label a couple of things. So knowing that this was where our x-intercept or our 0 was might be helpful, and that this was some type of discontinuity. That might be helpful just to remember down the road. Okay, so let's go to that sign chart plugging a 0 in. If I plug a 0 into the numerator x, so I'd have 3 times 0 plus 1, my output there is going to be positive. Okay, and if I do that in the denominator, if I plug a 0 into the first chunk, I'm going to get an output that's negative. And if I plug a 0 into the second chunk, that's going to be positive. So now I need to think a little bit, what is a positive number divided by overall a negative times a positive? What's that going to get me? Sometimes that takes a little bit of practice to kind of think through the general idea, but in the end that's going to get me something that's negative. Okay, so I know that in that chunk it's going to be below the x-axis. I don't know exactly what it's going to look like. What would be interesting in class is to kind of take this result and figure that out, but I know it's going to be below the x-axis. And then just like I did with polynomials, because I have an x-intercept or a 0 to the left of this area, and I know that that 0 has a multiplicity of 1, I know that it's going to go through at -1/3 and actually become positive over in this area. Now we could go through and do the same kind of sign chart, just like I did in blue for this area, but just as a shortcut I'm going to do it that way. So on the right side of that original chunk, so over here, I'm not exactly sure what's going to happen because graphically I would have a vertical asymptote right there. So I need to go through and do the sign chart sort of idea one more time for this. So I'm going to pick the x value of 2 now. So if I plug a 2 into the numerator, that output would be positive. Okay, the first chunk in the denominator would also be positive when I plug a 2 in, and the last chunk is going to be positive. So a positive divided by a positive times a positive overall gets me positive. And then I would do the same thing for the very left side. So maybe I think of, since, let me get my highlighter here, this area, -4 would be one of the easier numbers to work with, so I plug a -4 into all the x's up there. When I do that, -4 in the top part would get me negative. Okay, and then if I plug a -4 into both of the parts in the denominator, they will both be negative as well. So now I have to think, what's a negative divided by, in the denominator, a negative times a negative? Well, in the denominator, those two pieces multiply together, become positive. So I really have negative divided by positive, which overall is going to get me the idea of being negative. Okay, so that's kind of the work of the sign chart. Now we can take that and actually answer several different questions in example 5. So first they're asking, where is this overall idea going to be less than 0? That means where is it negative? So if we look at our sign chart, it tells us it's negative from -infinity all the way to -3. Now I'm not going to include the -3 because it doesn't exist there. The function doesn't exist. Okay, and then it's also negative starting at -1/3 all the way to 1. So that would be my answer for that. Okay, I'm basically going to have a lot of the same stuff in part B. The only other additional part is that now we can include where it's 0. So I'm still going to have negative infinity all the way to negative 3. I'm still going to have a parenthesis there because the function is not defined at negative 3. Okay, it's a discontinuity. But when I pick up again at negative 1/3, now I would have a square bracket because I can include that negative 1/3. That's where on the chart, that's why it's helpful to mark that it's a 0 versus some sort of discontinuity, going all the way to 1 now, not including the 1. Okay, and then C and D are basically, we're just, whoops, do not have this moved up like that. Basically the same thing, except now we're looking for where it's greater than 0. So I'm going to be looking at the other chunk. So for part C, just greater than 0, I'm going from negative 3 all the way to negative 1/3, not including any of those endpoints or end values. Then I'm going to pick up from 1 going all the way to infinity. Okay, and then for part D, again, the only thing that we would change is that we're going to include the negative 1/3 now, so a square bracket going all the way there, and then we go from 1 to infinity, not including 1. Okay, so that's going to be mainly what we do. So that, you got to make sure that that kind of idea makes sense. We'll look at a few more challenging things in class. And then I'll just quick do a little algebra review with you to finish off the rest of the video. Okay, so I'm going to go all the way up here. Okay, now what would we do if we had something like this where all the chunks are, we have several separate fractions. They're kind of simple fractions, but what would I do with something like that? Well, this process of a sign chart only works when we have all the pieces kind of multiplied together like we saw with that polynomial example, or if they are multiplication and division like a rational function sort of idea. So I need to do a little bit of work first in combining these two fractions, and the way that we do that is we create common denominators. So with my first fraction of 1 over x minus 1, what I need to do is kind of include the x plus 3 in the top and the bottom. Okay, that's just the second fraction that I had there. The second denominator, I guess, is what I'm including. Okay, and then for my second fraction, so 2 over x plus 3, I need to put in the denominator of the original. So that's going to be an x minus 1 on the bottom, but I need to put an x minus 1 on the top as well. So I am creating these common denominators. And I know I have the two denominators kind of flip-flopped, but that represents the same thing. So what I'm going to do is maybe just take the time to kind of simplify my numerators. So in my first numerator, if I were to really distribute that 1, I just end up with x plus 3. And that would be divided by x minus 1 times x plus 3. And then in the second fraction, if I distribute that 2, I would get 2x minus 2. And I'm going to just write the denominator the same way I did in the first fraction. I can just flip-flop those two pieces. That should not cause any issues. Well, now I'm at a point where I can actually combine these things. Excuse me. So when I add fractions, I'm actually going to add the common pieces together in my numerator. So an x plus a 2x gets me 3x. And a 3 plus a negative 2 gets me a 1. And I still have now just the 1 denominator, right, because we combine the fractions. And if you notice, that's exactly what our original question was asking. It was talking about this rational function. So if this had been a brand new question, you would have to go through all this work of now making a sign chart like we did up here. We've already done that work, and in this one they are asking where is it, let's see, less than or equal to 0. So basically in the end this is the same as part B above. Okay, we just kind of did all that work already. So that's just a little bit more of a complicated example of a way they could start the question. You need to make sure that the first part, the sign chart, makes sense.